That's as far as it goes. Shading, shading, no power for the batteries. You may remember video number 6 or 7 here on this channel. Way back in the time. I made the effort to sort out a couple of lithium batteries recycled from old tablets to replace the lead acid batteries in the solar gate with lithium batteries. And I spent hours and hours inside the garage to sort out these cells because they all had slightly different capacities. And I was trying to match the 7P. Here, these ones. You may remember them. All these stacks, they are sorted. So 6, it's a 7S 8P, an 8P7S battery, lithium battery. And since then, these packs are sitting here in the garage doing nothing. Because it was just easier to replace the lead acid batteries in the solar gate, and it worked again. And they are cheap. They are $25. And I think it was about 2 years ago when I replaced them the last time. And now they are dead again, and they are always dying when there's bad weather, when it's raining, and then you drive down with your car and the solar gate doesn't open because there's no solar and there's no gate, there's no nothing. When you need them the most, they are failing. So you have to get out in pouring rain, open the gate manually, get in the car, drive out, close the gate again afterwards, and then you can drive off and you're already soaking wet. And back then I also bought this EP Ever Tracer solar charge controller, an MPPT solar charge controller for the solar gate. It's a 24 volt solar charge controller, 10 amps, 60 volt maximum PV voltage. So totally sufficient MPPT. And I had a look here in the manual. You can actually Wi-Fi adapter or Bluetooth adapter. But I had a look online and these adapters are actually the same price as the controller itself. Because this one needs to go in the top box at the solar gate where the actual controller electronic sits in. And at the moment there is a small PWM controller, and this is obviously not great. And the system originally came with a 10-watt solar panel, and I already doubled this one up. This is the one on the mast, and this was still not enough in winter time when the battery is aged. So I installed these other 2 solar panels as well, and they've got like 40 watts each or so. So it's far overpowered. But now it's the 2nd or 3rd winter with these batteries here, and it's not working again. So I think the batteries are totally done. These are these 12 volt, 7.2 ampere hour block batteries, AGM prehistoric technology. Yeah, and reading in this manual here, it is actually a bit disappointing because you cannot program this device with these buttons here. You can only select a battery chemistry, and I think you can also reset the energy counter. And that's basically it. So everything else needs to be done through a RS485 communication port and the computer software, which I already did at some stage. I think I was connected to this device. I think I've got the software still installed on the computer, and I must have somewhere a... Let me have a look. Guys, welcome back to the Off-Grid Garage here in super nice and sunny Austria. Look at this beautiful early winter weather. We had lots of rain the last 2 days and the batteries are really down, so this is the first day we see the sun again. But it's early in the morning, we've got only 11.3 amps outside. 7% state of charge. Well, that's what you get in winter. So guys, in today's video we have to do it. We have to replace the old lead acid batteries in the solar gate with lithium batteries. Have to take off this PWM controller and have to install the EP Ever Tracer N. This was the smallest and cheapest one I could find. It's the Tracer 1206AN. We'll connect the solar on this side, the battery here, and the load, which is the actual gate controller, and the motors on this side. And back then I did some measurement on the solar gate actually to figure out what kind of power is needed. Yeah, so when the motors run, they use about 2.2 amps, but this is only for like 30 seconds or so, and then the gate is fully open. Another 30 seconds, they are fully closed again. So this is the maximum current we will see in terms of the load. The electronic inside uses around 60 to 70 milliamps constantly. And then of course we've got the MPPT solar charge controller as well, and the manual says it takes less than 12 milliamps self-consumption. There, 12 milliamps. And back in the day, I also bought this package here with, oh, you guess it already, huh? Ah, no, these are not the ones actually. Hang on, where are the other ones? Here we are actually. That's what I bought back in the day to make it work with the solar gate. Come on. The good old PALO battery. Huh? 7.2 ampere hours, the same capacity as the big lead acid AGM batteries in the solar gate. But we know from testing these ones get only around 5.5 ampere hours maximum or so. But this is totally fine because this is 5.5 ampere hour usable, right? While in the AGM battery we can only use like 3.5 ampere hours or so, the half of the capacity. But here lithium, full power. And I will have these soldering contacts here that come with these tin strips, so we can solder them together. And I've also, yes, I think that's it. This is the BMS I wanted to use for this purpose. The smallest JK you can actually get a BD4A8S4P. That is 0.4 amp of an active balancer, which is way too much for these small batteries here. It's an 8S, perfect for 24 volt, and a 4P makes it 40 amps in and out. Yeah, here. So 40 amps continuous and 80 amps peak. Yeah, look at this size. Smaller than my palm. And super lightweight, super small. And then we've got Bluetooth connection, so I can actually monitor the batteries in the solar gate just with my mobile phone when I go there. So yeah, this is basically everything I bought back in the day already to make this work, to make the transition from lead acid to lithium. What do you reckon? Can we make it work? So in the gate there are two of these lead acid AGM blocks basically. And they are sitting on top of each other like this. This is the space the batteries use in the solar gate. And if I put one of the PALOs on top, they're not much wider. So this should actually work. And in this box are 8 of the PALO batteries. So this is roughly the size what we actually need. This is probably only 60% of the space we are used for these two lead acid batteries. Okay, they sit in these holders and we can make any shape and size of battery. Oh wow, that feels like building a Powerball out of 18650 cells, right? Put enough holders here so we can actually arrange them and have them secured like this. Ooh, that sounds good. Because the plastic box at the front gate housing these lead acid batteries, it is a lot wider than the actual battery, so there's a lot of space in the actual box. So these batteries will perfectly fit in this direction in the box. And we probably put the BMS also in the battery compartment. And then we connect everything back to the solar charge controller, which sits in the box at the top. And the cables are already in place between the two boxes, so we can reuse them. The only thing I want to add is a fuse or something, because we are talking about lithium. So when we've got a short here, I probably put like a car fuse or something inside, 25 amps or something, just in case there's a short or whatever. Disconnects the battery and everything is good. Okay, let's put something together with these holders here and see how we can arrange these 8 cells. There are only 8 cells. So, and why not use the lithium batteries as originally anticipated? And I'm not really comfortable using these batteries. And this was a long time before we actually introduced lithium iron phosphate here to the channel. Yeah, and these ones are so easier to use. And we've got all the equipment there for it. So I'm not sure. I don't know. Maybe let me know in the comments down below. Should we use these batteries, these old lithium ion batteries recycled at some stage? But I really want to get this solar gate up and running again, so I use the PALO batteries here for the moment. And I've got one holder already. Look at this. This is the space it would use. This is basically one of these batteries here. Wow. Guys, I'm really impressed how compact this battery will be. This is a 24 volt 7.2 ampere hour battery, and this is only a 12 volt 7.2. So this is half the space it uses. That is amazing. Okay, maybe a little bit more, but all right. I have now arranged all the cells, positive, negative, and we will have the most positive on this side and the negative over here. And then we do just the series connection of all the cells, and it should work out super cool. Alright, and there we have soldered our 24 volt battery. I know these tin strips, they are supposed to be welded, but I don't have one of these small spot welders. Can any one of you recommend such a small spot welder? And I don't want to spend a fortune on it, but as you may have seen, we may have another project here with repairing this this Ego battery. It has one faulty cell, and I need to replace all the cells inside this battery. So I need a bit of a spot welder anyway. So if you have a good one, put your recommendations down there. Shouldn't cost a fortune though. Okay, let's see what we have. Positive, negative. 13.5 volts only. What is going on here? Okay, let me check on single cells here. I don't hope they are totally discharged. 3.2. This one has only 0.9 volts. Ooh. 3.2. This one has 0 volts. Oh no, here you go. 112 millivolt. Holy shit, eh? 2 volts. Oh shit. 3.1. 38 millivolts. Oh wow. And 866 millivolts. Oh guys, that's not good. I didn't look after this battery well, did I? It was sitting in the cupboard here for, well, since I bought it 2 years ago, and I never looked at these cells, never ever. So some of them are really low in voltage. What are we doing? What are we doing? What are we doing? Are we just connecting the BMS and let it balance and see what we get? Yeah, I think so. Okay, I've soldered all the balance cables now to the battery. And let's measure, see if we are in the right order. So the voltages could be all over the place now. 3.2, 4.1, 7.3, 7.4, 9.4, 12.6. Why is this the same? 12.6, 12.63. Ah, this was the one on 30 milliamps or so, millivolt. 13.5, and the very last should be 13.5 as well. Yeah, 13.5. Oh wow, shitty. That is not good. Let's connect the battery negative to the BMS negative, which is the blue one, not the black one. And connect the balance cables. Look at this. G-Kong put a power button in the box. And we also have temperature sensors. So the app doesn't complain. Okay, big moment. Let's turn it on. Well, it starts. That's a good sign. Okay, let's do a search. It must be, here it is, BD4A8S4P, that's the one. Yep, connects. Now look at this, cell number 2 and cell number 4, 7 and 8 are all missing. Cell count is not equal to settings, of course not. It thinks it's a, shit, it thinks it's a 12 volt battery. Wow, that is bad. See cell number 5, 1.6 volts only. All right, let's, introduce some charge here. 25 volts is fine. Negative goes here to the BMS and positive here to the battery. Charge MOSFETs and discharge MOSFETs are still off here. Okay, charge on. Discharge on. Cell count is not equal. Lithium iron phosphate. Okay. 7.2 ampere hours. 7. Oh, I can't type a decimal point. Okay, 7 ampere hours. Okay, I'm not too worried about these settings here at the moment. Balance. We probably leave the balance here at 3 volts at the moment, yeah, because we really wanna start the balancing factor. The balancer is off as well. Balance is on, charge on, discharge on, but this turns off after a moment again. Because, shit, we have to manually recharge these batteries here a bit and give it a bit of a head start. So cell number 2, for example, 4.2 volts, that's fine. Okay, positive here, negative here. Yeah, it takes 1 amp. And we can see in the app now cell number 2 is coming back to life. If I take off the power supply, does the voltage stay? No, it collapses again, huh? Slowly going down. Shit. Okay, charge it up to 3 volts or so. So the BMS actually recognizes it. 2.4. Charging with 1 amp into this poor battery. Have I destroyed all these cells now? Oh, shit. Okay, 2.5. So cell number 4 is the same. Needs some charge to be recognized by the BMS here. Cell number 4 is not showing. Ah, here it comes. 0.6 volts. Holy shit, eh? Don't show this on the internet. Oh, wow, that is really, really bad. Okay, let's leave this connected for a while here. Get it over 2 volts at least. Look how the voltage in cell number 2 is going down again. It's not holding well, huh? Okay, give it a bit more current here. 1.5 amps maybe. It goes a bit faster. We just need to get the charged MOSFETs and the balancer online, so the BMS can handle this all itself. And cell number 8, see, 1.5 amps, yeah, here it comes, 1.3, 1.5, 1.6. And cell number 7, I have to change polarity. Here we go, 1.4 amps, cell number 7, come on, cell number 7. Oh, really? Is it that low? Here it comes, 0.6 volts, shit. Yeah, and the balancer is on. Yeah, charge MOSFET is on now. Perfect. So I could potentially set it to 25 volts or something to get it started. Connect the negative to the BMS and the positive to the battery. And let it charge very slowly. 0.6, 0.5 amps, even slower maybe. Yep, here we go. 0.3 amps. Holy shit! That was not my intention to damage this battery. But now the balancer is working, as you can see, 0.4 amps, active balancing. And it should help bring all these cells back up again. So we just need to wait. I thought I put this battery together here, charge it up, and it can go into the solar gate. But nope. Nope. What's going on now? What is going on now? Has it just turned off? Has the BMS just turned off? It looks like it, right? It looks the BMS has turned off. Protection, cell under voltage protection. This is... Ah! Because... Oh no, it's still alive. What's going on? It's not reacting anymore. I can operate it, but it doesn't show the correct current anymore. Is there anything? It's what you always do. When you build a battery, do the sniff test. No, it's all good. Nothing gets warm. Nothing gets warm. So as per the power supply here, we're actually charging the battery with 0.8 amps, but the BMS shows only 0.3 amps. I turn off the BMS for a moment. Now it starts back up automatically. It did restart before, right? Okay, let's reconnect to it. Let's connect to another battery first. Okay, and then reconnect to this one. Okay, now it shows again. Warning, abnormal res of the balance wires. Holy shit, eh? Number 7. This is because the voltage is so low in number 7. It's not funny. But the voltage is climbing, so we ignore this message down there. I've never seen this before, actually. It thinks the resistance of this balance wire is somehow abnormal. But I think it's only because the cell voltage is so low. It's under 2 volts. The balancer is off again. Why is it off? Balance is on. It doesn't balance at the moment, see? Here again. It does a restart. So we need to charge this cell number 7 first. Okay, now the message has disappeared. We've got no abnormal balance wire resistance situation anymore. But we have a cell under voltage protection, of course, because cell number 7 is still so low. And I don't think it is actually balancing, is it? Ah, now it comes again, cell number 4. Okay, now we need to recharge cell number 4. Okay, let's see if this disappears. Look at cell number 7. It drops like a rock. I think they are done. I don't think we can actually revive these cells and reuse them. Okay, let me try to recharge these 2 cells here a bit so they're actually holding voltage above 2 volts. Because it says here in the settings somewhere, power off voltage 2.5 volts, see that? So as soon as one cell goes under 2.5 volts, the BMS stops working. And this is exactly what we see here. It just turns off. Okay, cell number 4 seems to be good now, 2.3 volts. I'm switching over to cell number 7 again. Charging cell number 7 now. We need to be over 2.5 volts with all the cells, otherwise the BMS turns constantly off. Because it's a protection. It's normal. Okay, give me a moment here. I recharge these cells and then we see how we go. Damn it! This whole project is off to a bad start. This is not good. Okay, it is now 45 minutes, an hour later, and a lot of things have happened since then. So I'm actually managed, just for you on the mobile phone quickly here, to keep all the cells over 2.5 volts, and the battery is now normally charging with 250 milliamps around. The active balancer is doing its thing. It's recharging cell number 7 and number 4. So I think we are good here. We just need to wait until everything is balanced and fully charged, which could take another 3 or 4 days or so. And I've also connected the EP-Ever MPPT solar charge controller with just 2 cables to the battery, yeah, 24 volts. Crocodile cables are your friend. And I have pulled out the USB to RS485 wave share USB adapter and connected A and B as per a manual I found online to the COM port of the Tracer N. And hell yeah, we've got an online view on the MPPT solar charge controller now. So now I can see all the settings of this device. And I think I was logged into this one here before. Under parameters, we've got a couple of parameters here, control parameters, exactly, that's where I want to go. So I've got control parameters and I've got control parameters for lithium batteries controller product. So I'm not sure which one to set at the moment. If I go in here, do a read, it reads all the parameters into the software here. And I've set this all up as good as I could. So I used the user profile basically here. This is the default. 5 ampere hours capacity, overcharge disconnect at 29.2 volts. This is a 3.65 times 8. Reconnect, equalization, we usually don't use with lithium products. 27.6, this is a 3.45 per cell. Boost charge voltage, the same. And float 26.8, which is a 3.35. And we've got a boost reconnect charge voltage, whatever that is. Boost duration 10 minutes. Equalization 1 minute. Charge limit voltage to 27.6, 3.45 again. Lowest should be 20 volts. This is 2.5 per cell. And so on and so on. So this is all I have for the control parameters, yeah. And I clicked on update, so I pushed all the information from the software back into the tracer, into the EP-Ever. But then I went also into the lithium settings and did a read. And it reads all the information now. Perfect. It has a lithium iron phosphate profile, but the actual, see what it doesn't keep are these ones here. We've got not 6, we've got 8 cells, not 6 cells. Okay, let me change this one here to lithium iron phosphate, and then I should be able to select 8 exactly. So Okay, and now all the settings are gone again. It somehow doesn't save it. Okay, let me try here. If I put this one to 30.99, I click on update. See, it switches to user again, and then it says operation successful. Because I've changed a parameter, I change it to user. Okay, get out of here, get back in here, back into control panel, read. Do we still have the... Ah, we still have it, okay. But here it has changed again, see that? Not sure if this is actually important or not. I don't know. Because it doesn't really do a cell level protection. Everything is based on the whole battery voltage situation. Unless I change this one here to lithium iron phosphate, but I don't like the settings. Yeah, then I can say we've got 8 cells for a 24 volt system, but the overvoltage disconnect is at 31.2 volts. This is far too high. And the charge limit voltage is at 29.2. This is too high either. This is 3.65 per cell. I don't want to charge that much. I want this one here on 27.6. Yeah. Then I click on update, and then the lithium type changes to user again. And it's all it is not greater than what? Now the parameters are not in the right order. Jeez. What a nightmare. Okay, let's start from here. Okay, let me set this up. I'll walk you through in a second. Hang on. Alright, I've set all the parameters now for the lithium profile now here. So disconnect is at 29.4, which is 3.65. Recovery 28, whatever. Boost charge 27.6, which is 3.45. Flow charging at 26.8, which is 3.35. Boost, reconnect, charge voltage, not sure what that is. Then we've got the boost duration. Is this our absorption time? I set this to 10 minutes now, I don't know. Equalization duration, 1 minute. And then we've got the under and over limit protection recovery situation stuff here to put in. And this updated also, it's in the BMS, so it's in the charge controller now, but I'm not sure. See, there's a bit of a limitation here with setting up this device, but yeah, I don't know. I probably don't even go all the way up to 3.45 volts with the battery, you know. I probably set this to a 3.4 volt per cell only because it sits there in the gate and it's not doing anything. So we don't need to charge to a 3.45 all the time. I probably have to come up with a maintenance thingy once or twice a year or something. After summer, before summer, we just do a top balancing and let it all go, or I'm not sure yet. So then we go out of here and that's pretty much it. So everything is set up, everything is programmed, everything else here in the software is monitoring, maintenance, import, export data, port, I don't know, for the load. I've set manually on by default, so the actual load output of the controller is on all the time, which I want. You can set up like street light stuff and everything, LED configuration, so the light stays on after sunset for a few hours before it turns off and all this kind of stuff. So yeah, I'm not sure. The only thing is it will be a total pain in the ass if I need to reprogram the controller down there at the gate, because I would need to take my laptop then with me with the software and a cable and plug this all in. Total nightmare. So I'm really thinking of getting a Bluetooth module for these EP-Ever. Is this something which works? Is it worth doing it? Leave your comments down below if you have one of them, or even a Wi-Fi would be even better. Does it connect to your home Wi-Fi, or is it just emitting its own Wi-Fi signal then? Because I don't want to open these boxes there all the time just to plug in a cable. This is pretty much everything I can do with the controller, so everything is set up. We probably should test this one, right? We should really test it. Maybe I can connect the power supply as the solar input and we use the controller to charge it. Yeah, we should definitely do some testing before I put it in the box down there, because this will be a total nightmare to work in this corner. All right, let's give it another couple of minutes here for the balancer to do its job on this battery to fully top balance it. And then we should be good. No, this will take for hours. Damn it. And I actually found a 9-year-old video from my good old friend Adam Welsh, where he explained how to connect the Tracer solar charge controller to RS485. And I've used this diagram here to put to build my own cable, and it has all worked. So thank you very much, Adam. I used to watch your channel back in the day to get my first knowledge of solar charge controllers and, well, RS485 as well. I wonder if he's still working in his shed there. So it is now close to 2 p.m. already, and we are still charging the battery, of course. Cell number 7 has now voltage increased to over 3 volts. So I leave the balancer running at 3 volts because we've got so huge imbalance here. This helps a bit to recharge cell number 4 and cell number 7 to catch up with the other ones. Apart from that, I have set all the parameters as per our standard. And now we just need to wait for the battery to fully charge. So it is already afternoon. I'm not confident that we do anything else today, but waiting for this battery to charge. And then do some testing with the solar charge controller and see if it actually charges the battery only to 27.6 volts or whatever we have set. I've already forgotten. Okay, I'll wish you a good afternoon and see you after the pft. So the battery gate is a 24 volt system. When I bought it like, I don't know, 8 years ago or something, it came with a solar panel, 10 watts, 2 batteries, electronics, these 2 boxes, one for the battery, one for the electronic, for the controller, all the motors, some cables and stuff. So everything was included in this whole package. And in the controller box, so that's the top box of the 2 there was also a 24 volt transformer, because the gate was supposed to be connected to the 240 volt grid, and the solar system and the battery was only a backup solution. Yeah, in case there's no power, the gate still opens then. So this was the whole idea of the whole package. But obviously this is not an option for me because there's no power at the front gate. Yeah, this is like 150 meter away from the house. There's no way I can dig a trench down there, and yeah, well. So at the beginning it was all working fine, but then in the first winter I realized quickly that the solar generated by this one 10 watt panel was not enough. I'm using around 1.6 ampere hours per day. This is what the motors use when my wife and I go in and out twice a day, so roughly, plus the 60 milliamps the controller PCB actually uses. So this all in total makes around 1.6 ampere hours. But the solar panel was not enough. There's a lot of shading down there from the trees and bushes, and especially in winter when the sun is a bit lower here, there's almost no sun anymore then. So 1.7 ampere hours is not possible. So what did I do? Of course, I increased the solar production. Yeah, I put another panel on top of this mast. So we've got 20 watts now, 24 volts, and it was good. It was working a bit longer. Not the whole winter, but a bit longer. So, and until the afternoon when I came home from work, the batteries were actually a bit recharged them from the solar, from the light during the day, and the gate was working again, yeah, in the afternoon then. But the next morning, same shit again. So I had to take out these batteries quite often, actually, bring them back to the garage, charge them manually for 5, 6, 7, 8 hours, and then bring them back down there on the gate so it actually works the next morning. Total freaking nightmare. And the annoying part is this always happens when the weather is really bad. Yeah, when we have thick clouds for 1 or 2 days, and then the third day it is not working anymore. The battery is completely depleted. The little PWM controller switches off the battery, then disconnects the electronic. It doesn't react anymore. I have to manually unhook the 2 gates, open them, drive out, close the gate, hook it all in, and then we can keep driving. And as I said, this of course happens always in the worst time ever. Yeah, cloudy, raining, storm, all this kind of shit here. And then you need to get out of the car. This is exactly what this gate was supposed to prevent, from us getting out in the car in the shittiest weather ever. So anyway, yeah, so the batteries, I have replaced these 2 AGM batteries, 12 volt, 7.2 ampere hours, I think 3 times now, at least. They last 2 years, and then it's done. But I checked the controller and it's actually not too bad, but it doesn't do any float mode or something. It just starts and stops charging the batteries and keeps them on 14.3 volts or something. And this is actually a bit high for a floating situation for these batteries. So I think they are getting constantly a tiny bit overcharged, and that's why they don't last as long. And from the beginning, I said, well, when these batteries die, I'm not going to buy new AGM batteries. I'm replacing this all and put lithium batteries in it, yeah? Because there's so much space in this box, yeah, I can easily double the capacity of the battery inside and can also hook up some LED lights there for the front gate and potentially some cameras or so, I don't know. Yeah, there's enough space to put fairly big batteries actually in this box. Okay, I would need to increase the solar production as well, which I did as well, you know. About, I don't know, 3 years ago or something, I hooked up these other 2 panels there, and they are 50-watt panels each, so that's 100 watts. Put them on the fence there as well as a temporary setup over winter. And you know what happens to temporary setups, you know? If they are working well, they stay. So I've got these 20 watts on the mast and these 100 watts of solar at the fence, which is mostly shaded as well, because otherwise the charging current would be far too high for these AGM batteries. Yeah, they can only do 0.05 C or something, so really small currents, and I cannot charge them with 100 watts. But because the panels are in shading all the time, we are not getting any high charging currents anyway. So I've got 4 solar panels now on this situation down there. The 2 AGM batteries, which are probably cracked or bloated or even both maybe. We will see when we take them out. And the PWM solar charge controller, the transformer I took already out of the top box. So there's enough space for the EP-Ever solar charge controller actually. Yeah, and hopefully this all works fine. And the system will run on lithium then after the big upgrade. So this is a project in the make since I have this YouTube channel here. Yeah? You may remember these older videos I mentioned before, yeah, when we sorted out these lithium cells and put them in packs of 8 to make sure each pack has roughly the same capacity as all the other packs. I spent hours and even days in here and had this all on this table here, and all the cells were measured, internal resistance and capacity, and I tried to mix and match them as close as possible to each other. And since then they are sitting on the workbench there, parked. I've never used them. Because then I started the journey into lithium iron phosphate, and it was so much easier to deal with that stuff. Far safer, huge capacities in these prismatic cells, so why would I bother with 1.1 ampere hour lithium ion cells, you know? And you need to parallel them somehow, need to put fuses in between and all this kind of stuff, so it is a lot of work. And this is a 8P7S system. That's a lot of fuses. And as you can see here, this is so much easier, right? Well, I should have looked at these batteries a bit better here and recharge them from time to time. I will actually have a look in this other box I had before. These are the silver ones. I think I have measured one. There's actually 5.9 ampere hours out of 2.7 as well. They are totally no-name thingies from AliExpress here. But this is another pack of 8 for another project I wanted to do. So I need to actually check all of them here and recharge them. But yeah, I think these PALO batteries here, they are brilliant for projects like this, you know. And I've got another 3 or 4 of these very small. Bought them at AliExpress for very little money. I think it was under $40 per BMS actually. And I bought them exactly for these projects here. And quite frankly, you always wanted me to do some 24-volt projects. There is one. But for these other projects, we can also use these lithium-ion batteries and some 18650 cells. I've got heaps of 18650s from old laptops here, and they still have here 1.5 and 1.1 ampere hours. So we can still use them for these projects. But if we use lithium ion, we can actually use some other BMSs I have here, some smaller GPDs and also DALI, because even with a 20 or 30 milliamp balancer, this would actually work with lithium ion, yeah, because we can start balancing so early because the voltage curve is so linear to the state of charge curve that is actually perfect for these very small passive balancers. And we don't need to waste a JK with active balancer for these batteries and projects. So I'm charging now for 2.5 hours. We're at 27.25 volts, still 1 amp going into this 8S battery. And have a look on the BMS app here. Our cell number 7 is now the highest. How does that work? I mean, I have really no idea why this cell has now flipped and has the highest voltage. So we're actually taking energy away from this cell and putting it into the other ones. Well, deviation has come down to 23 millivolt only, so that's good. We keep charging until we are balanced, satisfied, absorbed, and see how we go. That is probably not good, that this cell is now the highest.
2 weeks later.
I thought now after a week this project is already done and dusted, and we have changed the lead acid batteries in the front gate to lithium, but it looks like this video now turns into a battery repair video, because I'm still mucking around with this self-made battery made out of lithium iron phosphate cells. Let's turn on the BMS, and we have a protection cell under voltage protection. Cell number 7. So what happened is I did a full charge on this battery, yeah, to 3.5 volts or something per cell. Everything was nicely balanced, but I could see the voltage of cell number 7 was jumping around. Yeah, sometimes it was the lowest cell, sometimes it was the highest cell. So clearly there was something wrong. So I fully charged the battery, as I said, and then turned everything off. Left it as it is until today. This was like 3-4 days ago or something. And now when I turn on the BMS for the very first time again, so there was no load, nothing connected, you can see we've got an under voltage protection again, because cell number 7 is so low. So definitely this cell is not great. Now the BMS turns off, because we have hit the shutdown voltage of the BMS. Okay, let me turn on the charger here for a moment. Now, before we actually do that, I wanna use this bad boy here and measure the internal resistance of all these 8 cells. And yes, of course, it is linked down below. Okay, so we need to turn off the BMS, take out the balance cables, disconnect everything from the battery. So it's the pure cells without anything else. So we get an idea, 3.29 volts and 11.4 milliamps, yeah? And now cell number 7, so the internal resistance is twice as high as in the previous cell, almost 23 milliohms. Voltage is of course low. Okay, cell number 6, yeah, this one has 11. What was the other one? Number 4. Number 4 was a bit low as well when we unpacked the 12.35. It's a bit higher than the other ones, but I wouldn't be concerned about that at all. This is cell number 2, 12 milliohms, so this is in the same ballpark as cell number 4, 9. This is cell number 1, and I measure cell number 7 again. Wow, 23 milliohms, so we can already see this is the outlier in this whole pack. And the next thing I want to do is probably do a capacity test on cell number 8 and then cell number 7 to give us a comparison result and see what's going on. But I'm pretty sure we need to replace cell number 7. It is not holding the voltage, which is not too much big of a deal, because once it is installed in the solar gate, it will get a recharge every single day, basically, yeah? So it's not like we are keeping the pack for days like I did now with this test, without any charging coming in. So there will be a frequent and regular recharge in the solar gate. But of course, if the capacity is not there and it is significantly lower than in the other cells, well, there's no point using this cell anymore, and I have to replace cell number 7. Okay, let me set up the tester here, and then we do a capacity test. So we are using the CK E-Tech EBC A20. That is the small battery charger and tester. And I've connected it also to the computer because I want to see the charge and discharge curve of these cells and compare them. And this is a fantastic device to test your batteries and also battery cells, as we do right now. But it can also test batteries up to 12 volts, but only 130 watts or something. So it is a bit limited from the discharge current you can set, but connecting it to a computer and see the curves is priceless. Talking about priceless, I'll link all the information about this tester down below. I've made a ton of videos with this tester and the bigger one, the EBC A40L, the big Chinese cracker. 40 amps charging and discharging for single cells. Fantastic devices. All the information and some links to the videos are down below. Okay, let's connect to the device with the computer software and we do a charge constant voltage with 1 amp. Yeah, probably we use 1 amp. This is 5 hours then charging. Charge voltage 3.65 volts. Cutoff current 500 milliamps. Perfect. Okay, let's charge this one up first. This is cell number 8. And then we do a full discharge test, and then we do the same with cell number 7, and we can compare charge and discharge curves then. I'll be back in probably tomorrow or the day after. It will take a while. Guys, welcome back to... It's the same video. Well, it is actually 5 days later now, since the last scene, because I've done some excessive battery testing with our 24-volt battery here. Yeah, that was Monday, Tuesday, Wednesday, 5 days. Wow, it feels like an eternity. Okay, as I just said, I've done some cell testing now with cell 8, which is normal behavior, and cell 7, which is our problem cell. I haven't seen any results apart from one myself yet, so let's get surprised together. So what I have done with cell 7 and 8, I've done a full charge, a full discharge, and captured the data and the curve. And now we want to compare these. Cell number 7, we don't want the current here. So this is cell number 7, this is the problem cell, and the charge curve looks normal to me, right? Got a nice steep incline, then we've got the flat part of the charge curve, and then here we've got a smooth incline again until we hit 3.65 volts. And this bit here is absorption voltage for this cell. Okay, let's open the cell number 8 charge curve as a comparison. Charge curve here. We give this another color, maybe green. Okay, there we go. Okay, this looks a bit different, right? Not only can we see that we have a far higher capacity in cell number 8 than in cell number 7 here, but also the incline is here much smoother, and here it is more flat, and then all of a sudden the curve shoots up all the way up to 3.65 volts. So this looks a bit different here, more roundish, while this one here is it's more like a sharp corner. So cell number 7 obviously has only half of the capacity left than all the other cells. Okay, I would say this is not good. We definitely have a capacity loss here because we started at 2.5 volts, close to 2.5 volts, and we ended at 3.6. And cell number 7 clearly took only 2.4 ampere hours. All right, let's do the same for the discharge curve. Cell number 7. Okay, here again, discharge curve, we don't need the current. We are starting at 3.65 volts, close to it. Steep decline of the voltage, then flat, until here, until we hit like 3.13 volts. And from 3 volts, basically, it goes down very steep, all the way down to 2.5 volts here. Nothing unexpected, yeah? But we can already see we have only discharged 2.5 ampere hours out of this battery or cell number 7. So let's open cell number 8. Discharge curve, green. And here again, it looks like cell number 8 is holding the voltage a bit longer, yeah? It is a bit flatter, while this one looks like it is going down relatively early. There's only a flat part here actually at this point. And then here at 3.2 volts, it already goes down, down, down. It doesn't hold the voltage as good as cell number 8, yeah? So this is the takeaway. And again here, 2.5 ampere hours, cell number 7, and 5.6 ampere hours, cell number 8. So less than half of the capacity only. So this was the first 2 days of testing with this one. Then I did another test with cell number 7 only. I basically cycled it from 0 all the way up to 100% and back to 0% 5 times. And here we can see that, the 5 cycles, so there's nothing unusual to see here. Because the graph is fairly compressed now, it looks like the discharge curve is actually tapering off very, very quickly here. Okay, so here we can see the results of these 5 cycles with cell number 7, yeah? So it measures actually the charge and discharge capacity as well as energy for each cycle, yeah? 1, 2, 3, 4, and 5 is further down. So I was curious if the capacity of this cell actually recovers over time if we cycle the cell a few times. But from these data, it is not the case, yeah? 2.3, 2.2, 2.1, it's actually declining, 2.2, 2.2, 2.1, 2.2, it stays at 2.1, 2.2 ampere hours. So it has never shown any trend. So capacity is really not good. So this was another 2 days. And then yesterday to today, I did a... and then in the last test, I wanted to see how the voltage actually performs if we fully charge the battery and let it sit there for 12 hours. Yeah, how does the voltage decrease over time? And compare this between cell 7 and 8. Let me do cell number 7 rest voltage. I'll make this a bit bigger here on the screen. So this is the rest voltage basically, yeah. We disconnected the battery at 3.65 volts and then just let it sit there and measure the voltage over time. And this was over 10, 11, 12, 13 hours here. And after 13 hours, we still had 3.316 volts. So that is actually okay. 3.3 volts is the rest voltage. Maybe 3.35 even with a newer cell. But let's compare this to cell number 8. So we select green again, go in. And now you can see the difference, right? Look how good the voltage still is in cell number 8, yeah? And after, I cannot really... Now the data here with the right click only shows me the information from the first graph we ever open in such a diagram. But this line is 3.45, so we are close to, probably at 3.44 volts after 12 hours, close to 12 hours. While here we were at 3.316. So we can see actually that cell number 7 is not holding the voltage either, and it's further going down to 3.31 volts, while this one here is holding 3.44 volts over 12 hours. So these were all the tests I did in the last 5 days. Thankfully, we've got some spare PALO cells here. These are the exact same models as these ones. And this is the 4S battery we have used quite a lot here to test batteries and balancers, and parallel actually these ones here with a 304 ampere hour battery, and see how the current distributes between the high capacity cell and this tiny cell in comparison. So I'll probably do a capacity test on all these batteries here and see which one matches the best into the 8S battery we want to build. And then I just have to unsolder. Oh shit, that's a lot of work. Unsoldering everything because I have to take off this plastic frame here again. Damn it. Well, anyway, I will do this, repair the battery, replace cell number 7 with one of these. And then we should be finally good to go. Man, I tell you, I was planning to finalize this project within 2 days. At least we have sorted out the MPPT solar charge controllers. At least I hope so. But once the 8S battery is operational, we have to connect this to the MPPT, connect it to a solar panel or to a power supply here, and see actually what the controller does. How far does it charge? How does it behave? Does it go into float mode? All this kind of stuff. I don't know. I don't know these EP Ever Tracer N controllers here. Leave your comments down below if these controllers can do float mode with lithium batteries. But we definitely have to test this before we put everything down there in the front, in the solar gate. Once everything is working, we just install it down in this corner. There's just limited space, you know, so. Okay, my friends, I think I'm ending this video here, building my first 24 volt battery which turned into a battery repair video now. But at least we've got a good understanding now about these PALO cells here, and we definitely can say something has happened with cell number 8. Cell number 4 was low on voltage as well, but it doesn't look like it has done any damage. I'll probably do a capacity test on this one as well, just to get an idea what the remaining capacity of this cell is. And I've also checked all the other silver PALO cells I've shown you before, these 8S, for a different project. And there was only one cell was at 2.2 volts or something, so not too bad. And I recharged them all to 3.25 volts or something, because they are sitting in the box in the cupboard here for a year, 1.5 years or so. So they definitely self-discharge 3 to 4% a month. And this was obviously enough for this one PALO cell number 7 here to die. All right, my friends. Oh yeah. Guys, thank you so much for 110,302 subscribers. Thank you very, very much. That is freaking incredible. And thank you so much for your ongoing support here. This all helps out and makes these videos possible. Thank you very, very much for a ton of your comments under all these videos. I'm a bit behind with reading, replying and commenting myself, but other people are helping out. I've seen that, so thank you very much for everyone who is answering questions in the comment section, helping the community members out. That is very much appreciated and helps me out a ton. And please, as you know, do not send me emails. Some of them are so long you need to scroll and scroll and scroll and scroll, and then it says, all the best from Spain, Carlos. I would love to read the email from Carlos from Spain, but it's so long and has numbers and calculations in it and everything. That would take me hours to understand this project, and I'm sure he's got questions about something, and I would love to chat with Carlos. But if I send him an email back and say, can you explain this and this? You go into a conversation, you know? This all takes up a lot of time. If it would be only Carlos, it would be fine, yeah? But there's also Peter, there's Marcus, there are about 50 emails coming in every week with requests and questions and everything. Leave everything down under the videos, guys. Other people read this and give you the answer. I'm reading this, I'm giving you the answer, but not via email, just down in the comment section, please. And thank you very much, Carlos from Spain, for sending this email. As always, guys, until the next video, guys, when we hopefully continue with this project and building this 24-volt battery for my solar gate, because we still need to get out of the car and open the gate manually. It's just a pain in the ass, right? So I really want to focus on this project at the moment because it is so annoying to open the gate manually all the time. So until the next video, guys, you stay charged, stay safe, and thanks again for watching. See you then. Bye-bye.